Okay, hot water is dripping through a coffee maker. Hot water is dripping, filling a large cup. So I gotta just make sure I comprehend that. So, got me a cup, got water dripping into this. Okay. Here's a keyword: the amount of coffee in the cup. So the amount in the cup. At time t, it's given by a differentiable. Sometimes that's important. Function c. So right there, I'm going to stop. I can see I'm doing an amount rate thing here. So my amount is C of t, amount of coffee in the cup. Okay, they give me units here. Just want to keep track of units, minutes, and ounces. Selected values of C. Always selected values for tables. Okay, so we're good. So I know where I'm at with the information. The information is basically telling me there's an amount of coffee in a cup, C of t. Part A. Use the data in the table to approximate C prime of 3.5. Okay, if C is the amount of coffee in the cup, C prime is the rate at which that amount changes. I'm trying to find the rate at which the amount of coffee is changing at time 3.5. What we do is we say, well, we cannot from a table find how fast the coffee the amount of coffee is changing at an exact time. There's no way to do that with a table. So what we do instead is we say, well, let's see, this looks like the right time block here. So we're really using the mean value theorem. We're going to say that for this time block, the secant slope here, or the average rate of change of C, I'm going to find the average rate of change of C, which is the same thing as the secant slope of C, we're going to find the average rate of change of C, or the secant slope of C, for the time interval 3 to 4. Because the mean value theorem says that the average rate of change for this time interval, whatever that average rate is, because this function c is differentiable, that means there is a tangent slope somewhere on this interval that will be the same as the secant slope, which means there is a instantaneous rate of change of c somewhere on this interval that will match the average rate of change. So by finding the average rate of change of c, it's a pretty good estimate for the instantaneous rate of change of c on that interval. So they're asking us to find the instantaneous rate of change of c. We're going to estimate that. It says estimate, approximate. We're going to estimate that by finding the average rate of change of c. And there's a box on the golden notes to remind you about that. It's right here. You approximate an instantaneous rate of change by calculating an average rate of change. Notice the symbols. Our case would be C prime of 3.5 is going to be approximately equal to the average rate of change of C. So that's what we're going to use. We go back over here, show the results of the work. Here I am. This is the average rate of change of C. I'm saying that C prime of 3.5, the idea of the mean value theorem here, is approximately equal to C of 4, subtract C of 3, divided by 4 subtract 3. The blue, I can't leave that as my answer because I can't leave things in terms of function notation. So I have to have the red box to get 1 point. Don't have to do anything further, no computation required. They did tell me to use units, so I get a point if I write down ounces per minute. If that's upside down, you don't get the point. So 2 total points for 3A.